Hello everyone, welcome back to our channel gsipucmysuru. MYSURU. This is the fourth session of our 8th chapter, modulation and demodulation. In the last session we solved some of the problems, and in today's session we will be deriving an expression for the modulation index, that is MA, in terms of VMAX and VMIN. Before that, I will be solving another problem. By doing this problem, we will be covering with all types of problems from this particular topic. Okay. So, the next problem is a carrier amplitude to a depth of 50% by a sinusoidal produces side frequency of 335 kilohertz and 337 kilohertz. A carrier amplitude to a depth of 50%. To a depth of 50% and it is nothing but the modulation index which is given in percentage. So, percentage MA is equal to 50%. ಹಾಗಿದ್ಮೇಲೆ just MA is equal to 50 divided by 100, which gives me 0.5. Sinusoidal produces a side frequency of 335 kilohertz and 337 kilohertz. Side frequency, that is sideband frequency. So, out of these two values, whichever value is the lower value, that can be considered as the lower sideband frequency, and which value is higher, that can be considered as a higher sideband frequency. So, 335 and 337 are given. Out of these two, 335 is the lower value. So, FLSB, that is the lower sideband frequency, is 335 kilohertz, and the upper sideband frequency is given as 337 kilohertz. Okay. The amplitudes of each side frequency is 15 volts. The amplitude of each side frequency response ಬಗ್ಗೆ ಅವರು ಹೇಳ್ತಾ ಇದ್ದಾರೆ. This is the frequency and this is the amplitude. Here I am having an amplitude of VC whose frequency is FC, and here we will be having two sideband signals. One is called as FLSB, the other one is called as FUSB, which is equal to FC minus FM, whereas this is FC plus FM, and amplitude of these two is MAVC by 2. MAVC by 2. Here in this problem, the amplitude of each sideband frequency is 15 volts. Andre idanna avaru 15 anta heltidare. So, MAVC by 2 is equal to 15 volts. Find the frequency and amplitude of the carrier signal. Carrier signal, the frequency, that is equal to FC, and amplitude of the carrier signal, that is equal to VC. We have to find these two, that is FC and VC. FLSB is equal to FC minus FM. Houda? FUSB is equal to FC plus FM. Let us call this as equation number 1 and this as equation number 2. Now adding 1 and 2, FLSB plus FUSB is equal to LSB value is 335, FUSB value is 337 kilohertz. Houda? But FLSB is FC minus FM, FUSB is FC plus FM, which is equal to 672 kilohertz. Houda? FM cancel ಆಗ್ತದೆ. I will be left with 2FC, which is equal to 672 into 10 to the power of 3, or FC is equal to 336 into 10 to the power of 10 to the power of 3 hertz. That is, FC is 336 kilohertz. Houda? FC value is found out. Now, MA into VC by 2 is equal to 15 anta namge kottidare. Here I have to find out this VC value where MA value is given. So, MA VC by 2 is equal to 15. VC is equal to 15 into 2 divided by MA. 15 into 2 divided by 0.5 gives me 60. VC is equal to 60 volts. So FC value is 336 kilohertz and VC value is 60 volts. So with this problem, we will be completing all different types of problems which can be asked in this particular topic, that is instantaneous equation of an amplitude modulated wave. Now we will be deriving an expression for the modulation index in terms of V maximum and V minimum. In order to derive an expression for the modulation index, that is nothing but MA in terms of V maximum and V minimum, we have to consider only a single portion of the amplitude modulated wave, which gives us the maximum and the minimum values clearly. So if I am going to consider this as the graph, which gives me, this is the VC, above VC, and it will be decreasing less than VC. So this is the graph. Here the frequency of this amplitude modulated signal is same as the frequency of the carrier signal. That is, the frequency of this particular signal is very very high. ಹಾಗಾಗಿ ಅದರ ಒಳಗಡೆ ವೇವ್ ಫಾರ್ಮ್ಸ್ ಅನ್ನು ನಾವು ಈ ತರ ಬರಿತಾ ಇದ್ದೀವಿ. ಓಕೆನಾ? This is VC, whereas let me mark these points. This entire thing from the zero axis line, this is VC, whereas this can be considered as the V maximum, that is the maximum amplitude which will be reached by a carrier signal whenever the positive half cycle of a modulating signal is appearing. Positive half cycle of a modulating signal bandaga VC will increase. Negative half cycle of a modulating signal varvaga the amplitude of VC will decrease. So this is the maximum amplitude, whereas this will be considered as a minimum amplitude, that is V minimum. Then this difference will be considered as Vm only. So this and this is Vm, which will be changing, or the amplitude of this carrier signal will be changing in accordance with the amplitude of this modulating signal. So here VC will be considered as the reference line, not the zero axis line. Zero axis line na ನಾವು ಇಲ್ಲಿ reference ಆಗಿ ತಗೊಳ್ಳಲ್ಲ. We are going to consider this VC, that is the amplitude of a carrier signal, as the reference line, and the amplitude of this carrier signal will either increase or decrease depending upon the amplitude of a modulating signal. If the amplitude of a modulating signal is increasing, then the amplitude of a carrier signal will go above the VC line. If the amplitude of a modulating signal is decreasing, then the amplitude of a carrier signal will go below the VC line. That is, this itself will be considered as the axis, the reference point. Right? Now, according to this picture, V maximum, according to this picture, this is V maximum. V maximum can be written as from here till here, this is the zeroth line, from here till here, it is VC. VC plus Vm ಎರಡನ್ನು add ಮಾಡಿದ್ರೆ we are going to get V maximum. So Vmax is equal to VC plus Vm. Similarly, V minimum is equal to, this height is VC, whereas this height is Vm, but I want this height. So what we are going to do, VC minus Vm gives me V minimum. VC minus Vm. But we know that MA is equal to Vm divided by VC, but Vm is equal to MA into VC. How the? I have just cross multiplied. I am using that particular expression in these two equations. Let us call this as 1 and 2. So substituting for Vm from that, V maximum is equal to VC plus MA into VC, whereas V minimum is equal to VC minus MA into VC. Hoda? If I am going to add these two, Vmax plus V minimum equals VC plus MA VC, this term, plus VC minus MA VC. In this, MAVC gets cancelled. So this is equal to 2 times of VC. So VC is equal to VMAX plus V minimum divided by 2. I have just cross multiplied. You have to remember this particular expression. Now let me subtract V minimum from Vmax. So Vmax minus V minimum gives me Vc plus Ma into Vc minus of Vc minus MAVC. That is minus of Vc, minus into minus plus. So plus MA into VC. Ivaga ಏನು cancel ಆಗ್ತದೆ? VC gets cancelled. So Vmax minus V minimum is equal to 2 times of MA into VC. ಹೌದಾ? Now what we are going to do is ಇಲ್ಲಿ VC ಗೆ I have already got an expression of Vmax plus V minimum by 2. I am going to substitute in this particular expression. So 2 times of MA into Vmax plus V minimum divided by 2. Illi VC jaganal I am just substituting this particular expression equals Vmax minus V minimum. Here 2 and 2 gets cancelled. So I will be left with MA into Vmax plus V minimum ide. I will be considering this as the entire term. Vmax minus V minimum divided by Vmax plus V minimum. So this is the final expression for the modulation index in terms of Vmax and V minimum. MA is nothing but the modulation index that will be given by Vmax minus V minimum divided by Vmax plus V minimum. So even this derivation will be asked for your exams for 3 marks. So in this particular topic also we will be having some of the problems. We are going to solve that. So what you are going to do in this particular expression, first you have to write a particular diagram of an amplitude modulated wave. You are just going to take a single portion of an AM wave. In that particular AM wave, we are not going to consider 0 as the axis line, we are going to consider VC as the reference line. So the amplitude of this carrier signal, that is nothing but VC, will vary in accordance with the amplitude of a modulating signal. For every positive half cycle of a modulating signal, Vc will increase. For every negative half cycle of a modulating signal, Vc will decrease. So accordingly we have written this particular diagram. V maximum is nothing but the maximum amplitude reached by this Vc, and that V maximum will be given by Vc plus Vm. V minimum is nothing but the minimum amplitude which is reached by the carrier signal, which will be given by Vc minus Vm. Once we are going to add these two equations, again we are going to subtract these two equations, and finally we will be getting an expression of MA equals Vmax minus V minimum divided by Vmax plus V minimum. Clear? Just now we derived an expression for the modulation index in terms of V maximum and V minimum. The same modulation index can be written in terms of I maximum and I minimum, that is the modulation index in terms of current expression anda bandaga MA equals I max minus I minimum divided by I max plus I minimum anta. I max nothing but the maximum current which is reached by the carrier signal, and I minimum is nothing but the minimum current. Now we are going to solve some problems on this modulation index in terms of Vmax and V minimum. The first problem is the output of an amplitude modulator is found to have maximum and minimum amplitudes of 12 volts and 4 volts respectively. Maximum amplitude of 12 volts and minimum amplitude of 4 volts. That is Vmax is equal to 12 volts and V minimum is equal to 4 volts. Calculate the modulation index. Modulation index anta helidre it is equal to MA, the carrier amplitude that is equal to Vc, and the signal amplitude that is equal to Vm. You have to find out the modulation index MA, carrier amplitude and the signal amplitude. Just now we derived an expression for MA. MA equals Vmax minus V minimum divided by Vmax plus V minimum. They have directly given the values of Vmax and V minimum. Just substitute those values over here and find out MA. Vmax is 12, V minimum is 4. So 12 minus 4 divided by 12 plus 4, which gives me 8 divided by 16, 0.5. So MA value is equal to 0.5. Vc is equal to Vmax plus V minimum divided by 2. I had told regarding this particular expression in the derivation, that is, you have to remember this formula anta helide. So Vmax value is equal to 12 plus V minimum value is equal to 4 divided by 2. 12 plus 4 is equal to 16 by 2, which is equal to 8 volts. So Vc is equal to 8 volts. So we have found out this Vc. Now we have to find out this Vm. We know that Ma is equal to Vm divided by Vc and Vm is equal to Ma into Vc. I have just cross multiplied. So Ma value is 0.5 into Vc value is equal to 8. So Vm value is equal to 4 volts anta barutte. So Ma is 0.5, Vc is 8 volts, Vm is 4 volts. Ma ಗೆ ಯಾವುದೇ ರೀತಿಯಾದಂಥ ಯೂನಿಟ್ ಇಲ್ಲ, so leave it as it is. And for Vc and Vm we are having volts as the unit, so you have to mention those units. Clear? Now let us move on to the next problem. An unmodulated carrier is 300 volts peak to peak. 300 volts peak to peak ಅಂತ ಹೇಳಿದ್ರೆ unmodulated carrier, that is the carrier signal before the modulation process. So Vc peak to peak is equal to 300 volts. Calculate the percentage of modulation, that is percentage Ma or capital letter M you have to find out when its maximum peak to peak value reaches 500 volts. Maximum peak to peak, V maximum peak to peak reaches 500 volts. So you have to find out the percentage modulation. We know that if this is Vc, this will be considered as V maximum. ಹೌದಾ? ಇಲ್ಲಿ ಕ್ಯಾರಿಯರ್ ಸಿಗ್ನಲ್ ಪೀಕ್ ಟು ಪೀಕ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. This is the carrier signal. Peak to peak ಅಂದರೆ positive peak ಇಂದ negative peak. They have given this particular amplitude. But I am not concerned with peak to peak value. I am just concerned with this particular value. So what I am going to do is Vc is equal to Vc peak to peak divided by 2 ಅಂತ ಮಾಡ್ಕೋತೆ. So it is 300 divided by 2, which is equal to 150 volts. So Vc value is equal to 150 volts. Similarly, V maximum is equal to V maximum ಅಂತ ಹೇಳಿದಾಗ ನನಗೆ ಈ ಥರ ಬರುತ್ತಲ್ಲ, ಇಲ್ಲಿಂದ ಈ ಮ್ಯಾಕ್ಸಿಮಮ್ ತನಕನೂ ಅವರು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಬಟ್ ಐ ಆಮ್ ನಾಟ್ ಕನ್ಸರ್ನ್ ವಿತ್ ದ್ಯಾಟ್. ಸೊ ವಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಈಕ್ವಲ್ಸ್ ವಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪೀಕ್ ಟು ಪೀಕ್ divided by 2, which is equal to 500 by 2, which is 250 volts. What do you have to find out? You have to find out the percentage Ma. We know that V maximum equals Vc plus Vm, where Vm can be written as Vc plus Ma into Vc. This is equal to V maximum. But I want Ma, Vc ಗೊತ್ತಿದೆ ನಮಗೆ. So here Vc is the common factor. 1 plus Ma equals Vmax. 1 plus Ma equals Vmax by Vc, or Ma equals Vmax by Vc minus 1. So Ma equals Vmax value is 250. Vc value is 150 minus 1. So 250 divided by 150 gives me 1.66 minus 1. So Ma value is equal to 0.66. Ma value is 0.66, but they have asked for percentage modulation. So percentage Ma is equal to 0.66 into 100 ಮಾಡಿದ್ರೆ 66% ಬರುತ್ತೆ. So percentage Ma is equal to 66%. So like this you have to find out MA and the percentage modulation or the percentage MA. Peak to peak they have given, but we are concerned with only the peak value, not the peak to peak value. So, we are going to divide these particular values by 2 in order to get VC and V maximum. Now, we will move on to the last problem of this particular type. The amplitude of signal and carrier of an AM wave are 4 volts and 6 volts respectively. That is, the amplitude of signal is 4 volts and the amplitude of carrier is 6 volt. The amplitude of signal anta helidre VM is equal to 4 volts and the amplitude of carrier andre VC is equal to 6 volts. Calculate V minimum of the AM wave. You have to calculate V minimum of the AM wave. This problem is very simple. V minimum is nothing but VC minus VM. So, VC is 6 volts, VM is 4 volts. So, V minimum value is just 2 volts. Clear? So, problems are very simple, but you have to remember those formulas. So, with this I will be completing all the types of problems with respect to this particular topic. In the next session I will be dealing with a new topic. Until then, take care. Bye bye.